And for today's video, we are finally going into topic 7, chemical bonding. And in this topic, we have 3 subtopics, and they are 7.1 valence electron and Lewis structure, 7.2 molecular shape, 7.2 intermolecular forces. And for this video, we will focus on 7.1 Lewis structure and valence electron. This is the first part of this subtopic, where we will look into why valence electron is related to the Lewis structure or how they are related. And also we are going to focus on ionic bond and also covalent bond. The first question might be, why bonding involved? Why we need to talk about bonding when we are talking about Lewis structure and valence electron? Because we want to achieve octet, because your molecule want to achieve octet. And we know that octet means 8 electrons around the central atom. And how can we achieve octet? It's either by donating electron or accepting electron. And we know that will form your positive charge ion and that will form your negative charge ion. And also we can achieve octet by sharing electron. So we are going to look into what is actually sharing electron. And going back to your octet over here, other than how to achieve octet by doing all this, what is actually octet? Octet is when your atom in a molecule achieve noble gas configuration. What is noble gas configuration? Noble gas, as everybody knows, noble gas is located in group 18, and group 18 will have 8 valence electrons. So we are trying to achieve the group 18 noble gas configuration, and the noble gas configuration for group 18 will be NS2 and P6. So the NS2 and P6 over here will give rise to your 8 valence electron, 2 plus 6, and that is what we are trying to achieve by donating electron, by accepting electron, or even by sharing electron. And the example of your noble gas configuration could be 2s2, 2p6, or it could be 3s2, 3p6, or even 4s2, 4p6. So the N will depend on what period we are located in or what is your atom that we are talking about. So next, when we say donating electron, accepting electron, and sharing electron, what electron are we talking about? Valence electron. So what is actually valence electron? In a simple way, valence electron is actually the outermost shell electron which will participate in the bonding. So it's the electron that you use to donate, to accept, or to share. So that you will form 2 types of bonding, your ionic bond and also your covalent bond. And we learn on how to determine the valence electron in your SPDF notation previously. So make sure you know how to determine your valence electron. First and foremost, let's look into ionic bond. So what is actually ionic bond? Ionic bond is the electrostatic force of attraction between cation and anion in an ionic compound. Bear that in mind, it will be a cation and it will be an anion because we accepted electron or donated electron. And we know that cation means we will be donating electron, and anion means we will be accepting electron. Okay, and who will normally donate electron and who will normally accept electron? Cation will normally be the metal, and your anion will normally be the non-metal. So in the other words, your ionic bond will normally form between metal and also non-metal, where the metal will normally be cation and the non-metal will normally be anion. The metal will be donating the electron to the non-metal. Okay, the example of ionic compound that you can have is as simple as NaCl. So in the NaCl, you know that your Na is a positive one, your Cl is a negative one. So your Na will be donating 1 electron to the chlorine. Magnesium will normally be a positive 2, your bromine will normally be a negative 1. Your aluminium, normally a positive 3 metal, oxygen, a negative 2 non-metal. Potassium oxide, where your potassium will normally be positive 1, oxygen normally negative 2. So look at that, that is your ionic bond between them. So your calcium oxide, you have your positive 2 calcium, negative 2 oxygen. So between calcium and oxygen, you are having ionic bond. Same like your aluminium fluoride, where your aluminium is positive 3 and your fluoride is negative 1. So between them, you are having ionic bond. So ionic bond is the electrostatic force of attraction between cation and an ion. How about covalent bond? What is covalent bond? Covalent bond is when the atoms are sharing electron and are held together by the electrostatic force of attraction between the shared electron and the nuclei atom. So the main thing over here, covalent bond is different from the ionic, is covalent bond are sharing electron. And when covalent bond are sharing electron, means there is no one donating electron or accepting electron. Therefore, in the covalent bond, there will be no cation, no anion. And normally, covalent bond will happen between the non-metal and non-metal normally, but some of the metal and non-metal are also actually covalent bond. Let's see. The example of compound that we can have for covalent bond is as simple as H2O is a covalent bond, and you can see that your hydrogen and oxygen is a non-metal. Your NH3 also a covalent bond, nitrogen, hydrogen again is a non-metal. PCl5, CO2, BCl3, all of them you can see that is a partner between non-metal and non-metal. So normally when it's a non-metal, it will be a covalent bond. But if you look at it, I have aluminium chloride. And you know that your aluminium is actually a metal. But why aluminium chloride is a covalent bond? It has something to do with the electronegativity between the aluminium and the chloride. Okay, so you can go and figure that out. Why is aluminium chloride also a covalent bond? Therefore, we cannot say that covalent is only for non-metal and non-metal, but we can say that it will normally between the non-metal and non-metal, but they are not forever right. Some of the covalent bond could be also between metal and also non-metal. So it depends on the condition, it depends on who is your metal and who is your non-metal. So be very careful with that. Next, we are going to look into the relationship between valence electron and Lewis structure. How should a Lewis structure look like and why do we need valence electron? First and foremost, let's look at the example of carbon over here. And from your previous knowledge, you have known that how to determine the valence electron of carbon. So the valence electron of carbon is your 2s2, 2p2. And the Lewis structure will depend on the valence electron, where this is the way that we draw the Lewis structure of carbon. Carbon starting off with the symbol, and then you have 4 valence electron, and we are going to place it like this. 1, 2, 3, 4. So when you are having an alphabet or a symbol, so in a symbol of it, you are going to have 4 faces, 4 sides. And before you pair up any of the electron, you need to put the electron singly first on every side, and then you pair up if you have any more electron. And that is how we draw Lewis structure. Next, let's go into another one. You have your magnesium over here. Your magnesium valence electron, obviously 3s2. And right now, you're only having 2 valence electron. So how should the 2 valence electron be arranged? You have your symbol of magnesium. The 2 valence electron need to be arranged singly first on any side of the 4. So you can arrange it like this, or you can arrange it like this. Or you can arrange it like this. So it doesn't matter which side you put in, but it does matter that the electron must be singly first before you pair up. Next, we have oxygen. Where oxygen, you can see over here from the SPDF notation, the valence electron is your 2s2, 2p4. So oxygen right now having 6 valence electron. And for the Lewis structure of oxygen, it should look something like this. You have your oxygen symbol. The 6 electron will be arranged 1, 2, 3, 4 singly first, and then you pair up 5, 6. So you can pair up to any one of them as long as they are already full. Okay, so you can pair up like this: 1, 2, 3, 4, 5, 6. Any one will do over here, but it will be wrong if you arrange them like this. If you arrange them like this, then your Lewis structure is wrong. Or if you're arranging it, or if you arrange it like this, then they are also wrong. Your Lewis structure needs to be singly first on the 4 side, and then you pair up. Okay. Next and last but not least for this example, we have chlorine. And your chlorine valence electron over here, 3s2, 3p5. And your Lewis structure of the chlorine should look something like this. You have your Cl. You can have single first. Of course, you need to put in single first. And then you pair up. It could be like this. Or it could be you put in single first. And then you pair up to anyone that you like. It's also correct. Okay. But it will be wrong if your 7 valence electron is like this. Do not arrange them like this. They are wrong. Okay, they are wrong. And also do not arrange them like this. They are also wrong. Okay, we don't do all this. We need to put it on the 4 side. You have 4 sides. And then you need to put in singly first. And then you pair up. That is what we are going to do. Alright, for the Lewis structure. So make sure you understand the basic of Lewis structure for today's video. Next, we are going into ionic bond in specific. We know that ionic bond involve cation and also involve anion. Okay, I have an example over here. I'm having potassium fluoride. So in the potassium fluoride, who going to be cation? Who going to be an anion? Simple. Who is the metal? Who is the non-metal? So over here, potassium is the metal, fluoride is the non-metal. So obviously, potassium going to be the cation, fluoride is the anion. Okay? And if the question is asking for, show the formation of ionic bond. So we are going to show the formation of ionic bond. What are we going to do? Show means you need to have the beginning, what happened, and what is the product. And my beginning over here is I'm starting with potassium. And potassium is a group 1 metal that having 1 valence electron. Okay, that is the Lewis structure of my potassium. And my Lewis structure of the potassium will react with my fluorine, and my fluorine having 7 valence electron. Because my fluorine is a group 17, therefore I'm having 7 valence electron, and that's how my fluorine look like. And when the question says show the formation, means you need to show them what happened. So what is happening over here is your metal potassium will donate the electron to the fluorine to become fluoride ion. So the metal only have 1 electron over here. The 1 electron will be donated and pair up with the single electron in the fluorine. So that is what happening. The electron in the potassium will be moving towards the fluorine, the single electron in fluorine, to pair up. So this red color arrow showing that how the electron move from where to where. Therefore, this arrow represents the process. Do not miss out this arrow. Make sure you have this arrow and showing clearly from where going into where. And next, show the formation will not be complete without the product. So what happened after the electron being transferred? Your potassium will then become positive. Your potassium will then become positive charge with no valence electron left, while your fluoride will be formed. where your fluoride will become a F minus ion with enough electron to become octet. So from the 7 just now, you accepted 1 from the potassium. So the fluoride ion right now achieve octet with 8 electrons around it. So you can see over here, the electron of the potassium has gone to the fluoride. So the potassium have no electron anymore, and the fluoride achieve 8 electron. And the charge produced positive for the potassium, negative for the fluorine. Okay? And where is the ionic bond being produced? The ionic bond is the electrostatic force of attraction between cation and anion. So the ionic bond will be sitting between cation and anion. I have my cation over here, I have my anion over here. I won't have a bond because they are only force of attraction. They don't really having a bond like this. They're only having positive charge, negative charge attracted to each other. So the force of attraction will be labeled, or the ionic bond will be labeled simply like this. That is my ionic bond. Your ionic bond or your force of attraction between cation and ion will be sitting between cation and anion. That's how we label the ionic bonding. And this will be the complete answer if the question asks to show the formation. What happens if the question say only draw the Lewis structure? If the question only asking for the Lewis structure of the potassium fluoride without asking the formation, what would be the answer? Then your answer would be as simple as just the product. Your answer will be just the product. So same thing. Alright, you're just going to have the Lewis structure product. And if the question only asks you to draw the Lewis structure of potassium fluoride, this will be the answer. If the question asks you to show the formation, this will be the correct answer. Bear that in mind, formation means you need to have everything at the beginning, what happened and what produced. Draw the Lewis structure means you only need to have that structure, and that's it. And when do you answer or when do you label this ionic bond is when the question say indicate the bond. Alright, when the question say indicate the bond, then you are going to label the ionic bond. Bear that in mind, your ionic bond will be sitting in between potassium positive and F minus. So do not put anything in between them, just put an arrow down and label ionic bond. And that is how we label ionic bond. Simple. Let's look into another example of ionic bond. We have on the screen magnesium oxide. So again, we need to know who is the metal and who is the non-metal. Obviously, the metal over here will be the magnesium, where it will be the cation. Oxide is the non-metal, where it will then be the anion. So obviously, magnesium will be donating electron, and oxide, your oxygen, will be accepting electron. So let's see how it goes. So let's see how the formation works. So I started off again with my magnesium. My magnesium is a group 2 metal, so you will be having 2 valence electron, okay? And my magnesium is now reacting with oxygen. Your oxygen is a group 16 non-metal, so we are going to have 6 valence electron. And your 6 valence electron need to be arranged singly first before pair up. And how the electron is going to move around? You can see that magnesium having 2 single electron, oxygen having 2 single electron. So the electron from the magnesium will be going to the single electron in the oxygen. Magnesium will be donating 2 electrons, so both electrons will be moving out. Moving to where? Oxygen will become O2 minus. So both of the valence electron from magnesium will be moving towards oxygen, moving towards the single electron in the oxygen. Alright, you can see over here. So the arrow is a single-headed arrow because we are donating the electron, we are giving the electron. Magnesium is not going to take it back. Magnesium will give the electron to oxygen, magnesium will give the electron to oxygen. Bear that in mind, the red color arrow showing the movement of the electron, make sure you show clearly from where to where. And what would be the product? The product will look something like this. You have your magnesium. Magnesium donated 2 electrons, guys. So magnesium will be 2 positive with no valence electron around it, if you realize, because both of them given to oxygen. So what happened to the oxygen? Oxygen will then achieve octet, and oxygen will be having all 8 electrons around it. Okay, oxygen will be having all 8 electrons around it, and the oxygen will be 2 minus because oxygen accepted 2 electrons from the magnesium. And where is your ionic bond? Your ionic bond is between the cation and anion. That is your ionic bond. You only label this if the question asks. If your question did not ask, then do not label it. Okay, or you can just skip it. Okay. So again, this is what we are going to answer if the question say show the formation and also label the ionic bond form. Okay. And what would happen if the question asks you to explain? If the question asking for explanation, what would you do? And the explanation just as simple as magnesium loses 2 valence electron, alright, to form Mg2+. Why? Because we want to achieve noble gas configuration. Another thing, what is happening? Oxygen. Oxygen gain 2 electron, forming O2- and achieve noble gas configuration. That is what happening to my oxygen. I gain 2 electron. Last but not least, the opposite charge between the Mg2+ and the O2- are attracted to each other and held together by the strong electrostatic force of attraction that we call ionic bond. Okay? And when the question asks you to explain, you basically are writing back what you have done above. So don't be nervous. Don't be worried about the word explain. It's just very simple. What are you doing above? Write it again in English words. That's it. And next, we are going into covalent bond. So the first example that I have for covalent bond today is ammonia. If just now we have the formation of ionic bond, now let's see what happened when we need to show the formation of a covalent bond. And the example today is ammonia NH3. So how do we start? We start off with nitrogen having 5 valence electron. Why? Because nitrogen is a group 15. So if you don't remember why you are having 5 valence electron or so, it's simple. Use the proton number, write the SPDF notation. Or it would be even better if you actually know some of them. So nitrogen, 5 valence electron over here. I have 3 hydrogen. How should I draw my 3 hydrogen? Simple. Hydrogen, hydrogen, hydrogen. So that you can do the reaction later on, the transfer of electron. And every hydrogen over here holding 1 valence electron. Everybody knows that hydrogen having 1 valence electron. Slightly different from the ionic, covalent is not donating or accepting electron. Covalent is sharing of the electron. And when it's a sharing electron means that no one is donating or accepting. Therefore, the arrow will be a double-headed arrow. You'll be using a double-headed arrow to show that the electron now is shared between who. So let's see how the arrow should work in your nitrogen and hydrogen. Can you see the single electron over here? Single electron in the N, single electron in the N, single electron in the N. Single electron in the H, H and H. And what happened, guys? Simple. Share between all the single. Alright, so the single electron and the N will be sharing with the single electron in the H. And bear that in mind, since we are sharing, the arrow will be slightly different. We are using a double-headed arrow. So, sharing between the electron, make sure you are showing clearly which electron sharing with which electron. Okay, you have another one over here. So, how many covalent is being formed? You can see how many arrow over here, guys. You can see 3 arrow over here. So, how many covalent bond? 3 covalent bond. And how should your product look like? Your product will look something like this. Nitrogen, you have 2 electron over here. The pair electron doesn't do anything. So you put in the pair electron that do nothing. And then you have 3 covalent bond that form. First one, second one, and also the third one. And that is how your product produced. Why suddenly we are replacing it with a bond rather than an electron? Because we know that in every single bond, we are actually having two electrons. The two electrons that you have over here is actually in the bond. Alright, it's in the bond. We are only represent the electron by using the bond. So you do not need to show this. It's okay if you just draw the bond. Okay, don't show the electron because the electron is already the bond. Bear that in mind. One single bond. Alright, one single bond means that you are having two electrons in it. Okay, so that's why single bond is already represent two electrons. Okay, so remember, do not do this, yeah? Do not do this. Okay, so your answer would be great enough if you just draw your nitrogen and just showing the covalent bond. Then it will be good enough. Okay, and I have a question over here. Where is the covalent bond? Obviously, if just now the ionic bond is between cation and anion, my covalent bond is obviously between my nitrogen, hydrogen, and that is all my covalent bond. All three is your covalent bond, so you can label them like this. So if all this is your covalent bond, what is this? That is what we call lone pair. That is what we call lone pair. Lone pair is the valence electron that do not involve in bonding. Alright, it's a pair of valence electron that do not involve in bonding. That is what we call lone pair. Okay? And if the question asks you to show the formation, that will be your answer. Everything of this. Okay? But what happens if the question only asks you to draw the Lewis structure? If the question only asks you to draw the structure, means you only need to draw the structure. And your structure will look something like this. Bear that in mind, you still have a lone pair, and then you have your H, and then you have your H bonded, and then you have your H bonded. And if the question only asks you to draw, that will be your correct answer. If the question asks you to show, then you need to show everything from the beginning. What do we have? What do we have? What happened? And what is being produced. Okay? Last but not least, let's go into the last example of today's video, carbon dioxide. So let's see how carbon dioxide works, and let's see how the covalent bond forms between carbon dioxide. So carbon is a group 14. We have 4 valence electrons. Carbon is a group 14 with 4 valence electrons. Oxygen, I have 2 oxygen over here, so I need 2 oxygen. And everybody knows that oxygen is a group 16 with 6 valence electrons. Alright, we have 6 valence electrons over here. That is my oxygen 1. And then you have another oxygen over here. So you have 2 oxygen. Okay? And how they are going to share the electron to achieve octet or noble gas configuration. Obviously, carbon right now is only having 4 electrons. Every oxygen having 6. So oxygen need 2 more electrons to achieve 8 valence electrons. Carbon need 4 more valence electrons to achieve octet. So what happened is, the single electron will share with the single electron of first oxygen atom. They will share like this. So oxygen, the first oxygen atom having another single electron, so oxygen will share again. So you share over here. And the oxygen, the first oxygen on top here is already full with 8 valence electrons. So we have another oxygen that you can share with carbon. The single electron in the carbon, the third single electron, will share with the second oxygen. And we have another one that will share with another electron, another single electron in the second oxygen. So how many covalent bonds do you think you are forming? Obviously, we are forming 4 covalent bonds if you look. So the covalent bond produced will look something like this. You have your carbon. The carbon will be forming 2 covalent bonds with every oxygen. If you look at it, carbon 1, 2. 1 bond, 2 bond with the oxygen. So I will be forming 2 bonds with the oxygen. And the oxygen having 2 lone pair. So the oxygen will be remaining with 2 lone pair. Okay? Another oxygen, carbon forming one bond, two bond with the oxygen. So double bond with the oxygen. So another two lone pair with the second oxygen. And that's how your carbon dioxide Lewis structure look like. So we will check the octet. So we can check the octet of the oxygen and carbon produced. If you look at your oxygen right now, you have 1, 2, 3, 4 electron, 5, 6, 7, 8. Remember, every single bond is 2 electron. So one bond is 2 electron, one bond is 2 electron. Oxygen achieve octet. Oxygen on the right, 1, 2, 3, 4, 5, 6, 7, 8. Again, oxygen achieve octet. Carbon from the 4 valence electron right now achieve octet. 1, 2, 3, 4, 5, 6, 7, 8. So everybody achieve octet in this formation of covalent bond. Makes sense? That's why we need to share electron, donate, or even accept electron to achieve octet. And what happened when the question asking for explain? So when the question say explain, you are going to explain what you have above by writing them in words. As simple as telling what do you have and how many valence electron you contribute. So I have 1 carbon, contribute 4 electrons to share with 2 oxygen atoms to achieve, the purpose is to achieve noble gas configuration. And then you have oxygen. Each oxygen atom, you have 2 oxygen atoms, but every oxygen atom need 2 electrons in sharing to achieve noble gas configuration. Last but not least, what attractive forces is being formed? The electrostatic force of attraction between the shared electron of carbon dioxide and nuclei of the atom is what we call covalent bond. So that is how we write the explanation if the question asking for it. Okay, bear that in mind, everything that you have on top is what we call formation. When the question say show the formation, then that is what we are going to answer. Simple. So we have learned a few new things in this video, the basic of the Lewis structure and the valence electron, and also the formation of the covalent and ionic bond, as well as their explanation. So thank you for watching this video, and if you think this video helps you, do give me a like and do subscribe to my channel for more videos. I'll see you in the next video. Thank you.